In the previous two lessons, I showed you how to write integration tests using the testing framework that allows us to run our application in memory and test containers for running our database. We solved the external service that we were depending on, the GitHub REST API using the WireMock library, and finally in this lesson, I'll demonstrate the complete picture when it comes to integration testing and show you the many test cases that I added behind the scenes. If you grab the latest version of the source code that's going to be available right under this video, you will find some new test cases inside of the integration test project. If I open up the Test Explorer, you can see I have 86 integration tests and all of them are passing. If you want to execute them, you can go ahead and press run, and this is going to take some time. Integration tests in general, because they depend on external services such as the database in our example or WireMock, are going to be slower to execute than unit tests, which typically complete in a couple of milliseconds. However, you can see that all of my tests complete in just about 15 seconds, which is something I'm pretty happy with considering that it's 86 test cases. Now, when it comes to what I'm testing inside, you will find all sorts of examples. Let's take a look at the habit test, for example, and you'll find test cases using the get endpoints, which returns a page collection of habit DTOs. There's also a test case that first creates a habit and then fetches all of them and confirms that we're getting exactly one habit back. I also added a helper method in the test fixture that's going to allow me to clear the state in my database so that I can make my tests more reliable. You will also see tests for filtering, for sorting, for data shaping, for fetching a single habit, determining if versioning is working as expected, creating a habit, updating a habit. Here's an example of sending a patch request. This one is particularly interesting because I'm creating a JSON patch document specifying the update habit DTO and the operation I want to do, and then I'm serializing that and sending it using this string content type. I can pass this value to the patch async method, and the reason I'm using Newtonsoft JSON is because this is what's required to work with the JSON patch document. The test is checking that I'm getting back a no content response, which means that my patch request completed successfully. I'm also sending a get request after the fact to confirm that the patch request actually updated the name of the habit. Lastly, there's a test for deleting the habit, and this pretty much tests all of the endpoints in our habits controller. You will find similar examples in the users test, which tests most of the respective endpoints. There's tests for the tag controller and what we have there. One thing that's interesting there, let me find it, is right here. When we are creating the tag, I'm resolving the tags options object, which configures what is the maximum allowed number of tags that I can have in the system. So I'm using this value to create tags so that I reach the limit, and then I'm sending an additional request and checking if I'm getting back a bad request. I could also make this more detailed by examining the response body and checking that the problem details contains the correct structure, but I think even something like this is more than enough. Another thing that's interesting is the entry imports test. This depends on a file to be able to complete the request, and I can create that by defining my CSV file as a string and then creating a new instance of a multi-part form data content. I can serialize my file into a byte array and use that to send a file request when calling post async. Then I can validate that I get back the correct response. So there's even an example of sending files inside of our integration tests. The other examples you'll see here are all pretty similar and are going to revolve around sending the CSV file to the respective endpoints and confirming that we get back the correct result. Inside of the authentication tests, I added some additional test cases to confirm the login and the refresh endpoints. The refresh endpoint is particularly interesting when you send multiple refresh requests, and here, because of some concurrency issues, I added a task delay to make sure that the tests complete successfully. So sometimes you have to make do with hacky solutions, but what's important is confirming the behavior of our endpoints. I also defined a cross-cutting concerns test where I'm validating some behavior that should be true in general. For example, I'm checking that my endpoints support authorization properly. I'm checking if resource ownership between different users functions correctly, confirming that I can send the various media types that I defined, checking that in case of an error, I get back a problem details response. So these are things that I would place under cross-cutting concerns, so I defined a separate test class for these types of tests. Feel free to grab the source code that's available right under this video and check out all of the test cases. As I said, there are 86 integration tests in total, which is pretty good for an application of this size. I didn't cover all of the possible use cases, but I think I covered most of the important ones, and in total we have 212 tests at the conclusion of this lesson. In our next lesson, I'm going to show you how to write functional tests, which are also called end-to-end tests, and these types of tests validate a more complex flow inside of our application. Instead of validating a single endpoint, we're going to confirm that calling multiple endpoints in succession produces the desired behavior inside of our system. Welcome to the next lesson in the Pragmatic REST APIs course, where we are going to talk about functional testing, also known as end-to-end testing, and inside of this lesson I'm going to demonstrate a couple of tests that cover a complete flow inside of our application. Let's go into the code and let me show you what I mean. If you go ahead and download the latest version of the source code that's going to be available right under this video, you will see a new project inside of the test folder. This is the DevHabit functional test project. Now, I didn't want to go through setting up all of this from scratch, as it's pretty similar to how we already configured our integration tests. So let me just walk you through the couple of infrastructure components. You will recognize the DevHabit web app factory. It's completely identical to the one in the integration testing project. We're setting up a Postgres container and a WireMock server. There's also the functional test fixture, which is also identical to the one in the integration test project. The only thing that's really different is the test cases. Now, the test cases for functional testing are pretty complex, and I didn't want to write them from scratch because that would take up too much time. Instead, I created them behind the scenes, and I'm going to walk you through a couple of representative examples. So I created tests for 4 flows inside of our DevHabit application, which should illustrate how somebody would use our application in the real world. So let's take a look at the examples, starting from the habit entry flow. I'm going to clean up the database inside of each test, just in case, and then I organize the tests into a couple of steps. You'll see comments before each step describing what the particular step does. So inside of the habit entry flow test, we're going to first register a new user. We'll send a register user DTO to the respective endpoint and validate that we get back the correct response. Then we're going to authenticate with the API by sending a post request to the login endpoint. In step 3, we're going to create a new habit for the currently authenticated user. In step 4, we're going to create an entry for this user, or to be more specific, for the habit that we just created. In step 5, we're going to create another entry for this habit. In step 6, I want to fetch all of the entries for the current user, and I'm applying a filter to specify the habit identifier. And lastly, I'm fetching the statistics for the current user and making sure that we have at least 2 entries. So you can see this is a pretty complicated flow. It would require somebody logging into our application, going through a couple of screens in the user interface to create a habit, to create a couple of entries, before finally going to the dashboard to verify the statistics. So this is my first functional test. Let me show you another one. Let's say the habit management flow tests. You'll see it's pretty similar. I'm registering a user, I'm authenticating with the API, I'm creating a habit. This time I'm creating a tag and then adding the tag to the habit using the upsert endpoint. Lastly, I'm fetching the habit by ID and then confirming that this tag is present in the tags collection of my DTO. In the GitHub integration flow, I'm combining what we already did with the WireMock setup, and I'm starting by registering and authenticating with the API. Then I'm mocking the GitHub API response, storing the GitHub access token, getting the profile for the current user, using the access token that we just stored in the previous step, revoking the access token, and then confirming that we can no longer get back a response from the GitHub controller's getProfile endpoint. So again, a pretty complicated flow consisting of many separate steps. And lastly, there's the entry import flow. I find this one the most interesting because we have to wait for the background job to complete to be able to process the file that we uploaded. So we are again registering, authenticating, creating a habit, then I'm creating a CSV file that's going to represent my import, sending this import to the entry import endpoint, and remember that this is going to kick off the background job that's going to be doing the actual processing. Now in step 6, we will be polling the API endpoint, trying to fetch the entry import job by the ID, and we are checking in the response that the job status is either completed or failed. Now before each step, I'm going to delay for 500 milliseconds, and I'm also going to give it a maximum number of attempts so that we don't end up waiting forever. After this completes, I'm going to verify that my entries were properly imported by sending a GET request to the entries endpoint, filtering based on the habit ID, and this should contain exactly the same amount of entries as we have uploaded in step 4. Out of the 4 functional tests that I just showed you, this one is probably my favorite because I think it demonstrates the most complex use case. We're interacting with the API, we're also waiting for the background job to complete successfully, we're polling our API to check the status of the job processing before making sure that our entries are also properly created. So let's go ahead and run all 4 of our functional tests. Now these are going to take quite a bit of time to complete because we're executing many individual steps where each step represents basically one integration test. Now even so, you can see our tests complete in under 10 seconds and all of them are passing, and with tests like these inside of our code base, we can have the highest level of confidence in our application. Now let me go ahead and run all of the tests inside of the solution, and let's make sure that they are all succeeding. And in total, this should definitely take 15-20 seconds, which isn't too long considering that about half of all of our tests comprise of integration tests and functional tests. And after a few moments, you can see that all of our tests completed and they are all passing. I hope you enjoyed this quick overview of functional testing our REST API. I demonstrated 4 complex flows inside of the DevHabit application, and you saw that all of our functional tests were passing together with the integration tests and the unit tests inside of our solution. In our next lesson, I'm going to demonstrate how we can do automated testing inside of CI/CD pipelines, and this also includes our integration tests and our functional tests.